So, you've done it. You've built your first vector search implementation, and that initial spark of magic, that wow moment, is maybe starting to fade a little bit. Now you're hitting the real-world headaches. If that sounds like you, trust me, you are in the perfect place. We're about to walk through all those common frustrations and give you a real, practical playbook to get them solved. And this, right here, is the most important thing to remember. You are not alone. Every single person who gets serious about vector search runs into these exact same walls. It's not a sign you did something wrong. It's actually a sign you're past the easy stuff and you're onto building something real. So let's put a name to these problems. Do any of these sound familiar? The search results just aren't hitting the mark. Your queries feel like they're taking forever to come back. That monthly bill from your provider is starting to make your eyes water. Or maybe your data is always just a little bit out of date. These are the classic signs, and we're going to figure out how to fix them. Let's kick things off with what is, for my money, the most frustrating problem of all: relevance. The whole reason you got into semantic search was to get results that understand meaning, right? Not just keywords. But then, sometimes the results you get back feel like they totally missed the point of what the user was asking.
Okay, let's take a super simple, totally reasonable query. A developer's looking for best practices for API authentication. Seems pretty straightforward. What could go wrong? Well,
And here we go. This is what makes you want to pull your hair out. The search comes back with stuff that's technically related. You get a general article on API design, something about HTTP, even a basic what is an API primer. But the one document they actually asked for, the one about authentication, it's completely missing. So what is happening here?
a lot of the time, this is the main culprit. It's a model mismatch. We all tend to start with a general purpose model, something like Mini LM, because it's easy and it works on everything. But it was trained on, the entire internet. A domain-specific model, one that's been fine-tuned on actual search tasks, is just so much better at picking up on user intent. It really is the difference between using a butter knife and a surgeon's scalpel for a precise job.
All right, let's pivot to the next big headache. And this is kind of the good problem to have, but it's still a problem: speed and cost. This happens when your app actually gets popular. Suddenly, that demo that was so snappy is starting to feel sluggish, and the costs, well, they're starting to get expensive. Now, when we think about what's making our search slow, we usually point the finger right at the vector database. But have a look at this. The search itself is a big chunk of the time, for sure, but it's not the whole story. You've got the time it takes to create the embedding for the query, and then you have this enrichment time. That's when you go fetch the full text of the documents after you get the IDs back. You've got to figure out where your bottleneck really is. And of course, there's the money. Infrastructure costs money, like your Pinecone pod. But the real kicker, the one that can sneak up on you, is the embedding API. Every single document you index, every query a user makes, it costs you tokens. And when you start to scale up, that can add up fast. Okay, enough complaining about the problems. Let's get into the good stuff, the fixes. I want you to think of this next part as your personal playbook. These are real, practical strategies you can use to boost your search quality, crush that latency, and get your costs back under control. For that pesky relevance problem, your secret weapon is hybrid search. It really is the best of both worlds. You run your fancy semantic search, but at the exact same time, you run a good old-fashioned keyword search. Then you just mix the results together. This way, you get the amazing conceptual understanding from vectors, but you also make sure you don't miss crucial keywords like authentication that the user explicitly typed. Now, what about speed? This one is a huge win. Just look at the difference here. Making a network call to an API for your embeddings can easily take 200 milliseconds. But if you run a model locally on your own machine, you can get that down to 20 milliseconds. That's a 10 times improvement right off the bat just by cutting out the network trip. And to bring those costs down, you just got to be smart. First, you don't have to use that top-of-the-line expensive model for everything. Use it for the live user query where quality is critical, but use a cheaper local model to index all your documents in bulk. Second, stop storing the entire text of your documents in your vector database. That's expensive. Just store an ID and then pull the full text from cheap storage like S3 only when you need to show it to the user. So knowing what to do is half the battle. But now you actually have to, do it. So let's wrap this all up with a super simple 3-step action plan that you can literally start working on this week to see a real improvement. Here it is, nice and simple.
First, just pick your biggest problem. Is it relevance, speed, or your budget? Don't try to fix everything at once. Second, just implement one thing we talked about. Pick the one that's going to give you the biggest win for the least effort. And third, and this is so important, you have to set up monitoring. You need to measure before you make the change and after, so you can actually prove that it worked.
And what does success even look like? It's not just a gut feeling. It's a number on a dashboard. It's seeing a 10% bump in search quality, or chopping your query time in half, or seeing that monthly bill go down by 30%. You have to define what you want to improve, make the change, and then measure it.
Let's leave it on this note. Hitting these problems isn't a sign of failure. It's just part of the journey. It's inevitable. But the solutions to every single one of these problems are out there, and they are absolutely learnable. Now you've got the playbook, so the only question left is, which problem are you going to solve first?